This is the tool breakage sensor by Allora International. This is the PCS-350 and also a demo of the PCS-ER Plus. Just kind of run through a teach sequence and also to help kind of understand the differences of the two units. This is the 350. It's servo controlled, and so it automatically tries to hold the position onto a hard stop here. This particular sensor is capable of teaching two different positions. You have sweep 1, sweep 2. They can only be taught in the exact same direction, so you could teach one position in here and another position here. The control pendant here has multiple settings for not only tolerance, but as well as the speed of the unit. Let me run through a quick example of the teach function. So if I press the teach button here, all I got to do is press this button here, move slow, and calibrates the end stroke point for the sensor. If I want to teach a second position here, I can hit this, it'll come down, teach a second position. Now, once the positions are taught, as an example, I hit this, it says it's good. It's green. I did teach the position up here, so if I press this button here, you can see that it is basically would fault the machine and stop the machine, and you'd have to go in and change the broken drill or reset the tolerance. So this tolerance switch here, as an example, we can go ahead and change it so that way the tolerances are larger or smaller depending on where we're at, as well as if we want to increase the speed, depending on the size of the drill. Obviously smaller drills, you're going to want to go at a slower speed so you don't break the drills. But since it's servo controlled and has the acceleration deceleration, at the slower speeds, that is one standout feature compared to some of the other similar tool breakage units out on the market today. Now, the pendant is not necessarily needed for the unit itself. Everything can be also done through the controller. There are some buttons on here, dip switches, etc. Though a lot of times for the machine tool operation, sometimes you can just install manual buttons for these physically on the front of your CNC machine, for example, or utilize a soft push button panel by the OEM. Your choice, what you want to do there. But so again, this one teaches it in both directions. I'm sorry, in a single direction, two different points. The PCS-ER Plus will actually teach it in two different directions. So a lot of times this would be great for like on a Swiss type of machine, where you'd put this in the middle of between one drill where you could hit this side, teach it, and then swing it back the other way and hit this side and teach it. So you only got to buy one sensor instead of two, as I don't believe there's any other manufacturers that have the capability of going one direction or the other. Again, this is servo controlled. Okay, for the PCS-ER Plus, same principle. Teaches one side, press the other side. It's a taught position. After that, you're just a matter of, again, one side or the other, adjusting your speed. Obviously, you want to increase the cycle time as fast as you can without breaking the tool and handle reliability. One thing that you can also do with these is to increase your cycle time is the drill does not have to necessarily stop. It can keep spinning. You can check an actual live tool as well. Now, when it comes to the differences, the PCS-350 actually has a hard stop for a home position, so it needs to be kind of rotated into place, whereas the PCS-ER Plus, you can basically sit at any position. Kind of went through the sweep direction, clockwise or counterclockwise, setting the point in one direction or the other, but the PCS-ER can go both directions for the teaching mode. These are both are brushless technology, so there's no dead spots, no. Some of the other ones out there have gearboxes, so there's a little more play and slop in them as well. The 350 has to have this particular control module here, whereas the PCS-ER Plus, if you're using can open, if any of your machines have a can open interface, you can basically program right through that interface and hook directly up to the sensor. Otherwise, you'll also need that control box as well. Internal library function and standard connectors. Now when it comes to the actual setup of the unit, you can see by the dip switch settings the various options that you have on the unit itself. You can set the relays, the fault relays, and what to either latch on all the way, or set them to be just a pulse that goes into the control, and which you'd have to find the error message or the tie-in for that. Or in a feed hold circuit case, that's oftentimes a lot of, for the older machines that don't have the fault alarms, you can run through a feed hold circuit and tap into that. So essentially there's two relays in there. One is an OK relay that would basically tell the machine to continue operation, or a fault relay. And you can set those to have either a normally open or a normally closed contact, or a normally open contact can be set for the operation just by the dip switch. When it comes to setting this fault tolerance switch here, you can see that by the tolerance chart that it's the total number of degrees, and what that's saying is just that when the actual a lot of times you get chip buildup around the wand, that kind of stuff, where you want to make sure that it's always touching, and it alarms out if for some reason it never makes it all the way there, or it doesn't come all the way back. You can basically program that to have different fault tolerances depending on your application. Keep in mind, this actual needle itself, the round type here, you could use this and bend this into a 90 degrees this way, and then bend it back to work its way around stuff in order to get better clearance here, and this will still function as needed.